Hey, Algebra 2, ladies and gentlemen, this is Mr. Heron coming at you with 3.3, talking about solving systems of inequalities. And solving systems of inequalities is almost entirely done on a coordinate plane, on a graph. So hopefully your graphing skills have not completely escaped you. Hopefully you got some back. So let's kind of take a look at what we're talking about here. So during one heartbeat, blood pressure reaches a maximum pressure and a minimum pressure, which are measured in millimeters of mercury. That's where, if you ever get your blood pressure taken, that's at mmHg, because Hg is the periodic symbol for mercury. So it is a maximum over the minimum, so like 120 over 80. 120 over 80 is your average, and it is your healthy range for blood pressure. So normal blood pressure ranges from 100 to 140 and from 60 to 90. So express this as a set of inequalities. So your range has got to be between 100 to 140 for your maximum, and then from 60 to 90 for the minimum. So you graph this right here, okay, from 60 to 90, from 100 to 140. So out of all blood pressures, this is the healthy area. That's the zone you want to be in. All right, so it's not exactly one number, it's a range, and that's kind of what you're looking for. So if I take a look here, Classy Catering needs at least 15 food servers and 5 bussers to cater a large party. In order to make a profit, they can have no more than 34 food servers and 7 bussers working at the event. So if I let X be servers and Y be bussers, so then X would just be, X has got to be greater than 15. X has got to be less than or equal to 34, so together, or greater than or equal to 15. So it would be 15 less than or equal to X less than or equal to 34. And then for Y, Y's got to be greater than 5. Y's got to be less than or equal to 7. So that would be, 5 less than or equal to Y less than or equal to 7. There's my inequalities right there. So boom and boom, and this is kind of that combination one. So if I look at graphing is where things get a little bit tricky. So what I got to remember is this. This means solid line. And so what I've got to do is graph this. So I'll graph this first one in black. So I'm going to put positive 4. I go down 2 over 1. So I'm just kind of drawing in the points. Solid line. And I want to test 0, 0. So 0 greater than or equal to negative 2. Times 0 plus 4. So is 0 greater than or equal to 4? No. So that means I'm going to shade away from 0, 0. So I'm going to shade that way. Here, y equals negative less than or equal to x minus 2. So if I do that, go at negative 2, go this way. That's what that looks like. Like I said, hopefully graphing hasn't really gone away. So again, test 0, 0. Well, is 0 less than 0 minus 2? So is 0 less than or equal to negative 2? That is going to be false as well. So 0, 0 doesn't work either way. So then I want to shade what's in common. So there is my common area right there. So each time I'm going to graph, and then I'm going to test 0, 0. Why do I test 0, 0? Because 0, 0 is an easy point. It's easy to put in 0 for x and 0 for y, and it's just kind of nice to say, hey, does this work, does it not work? So solve the system here by graphing. So y is less than 3, and then y greater than x minus 1. So y is less than 3, so that means y is less than 3, y is greater than negative 3. So if it's just like that, that means it's going to be dotted. So y less than 3 is going to be right here, and it's going to go down. Y greater than negative 3 would be right here, and again dotted. That's going to go up. All right, so now if I look at this one, the second one, negative x, or x from minus 1, that means I'm going to start there. I'm going to go up, 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 up. So it's going to look like this, solid line all the way through. Then I got to test which way I'm going to graph. So if I put in 0, 0, 0 greater than -1, is that true? 0 greater than -1, that's going to be true. So I want to shade towards 0, 0. So the part that's in common here is going to be this. That's going to be my solution area. So now, slope-intercept form is always nice. Slope-intercept form makes graphing significantly easier. So if I go graph this first one here, so that's going to be at +4. I go up 1 over 4, so working back, that means I go back 4, down 1. So that's going to look like this, solid line. Then if I test 0, 0, 0 greater than 1/4, 0 plus 4. Is 0 less than or equal to 4? That's true, so I want to shade towards it. So if I shade here, if I look here, that's going to be a -2, up 1 over 4. So these are parallel lines. Hopefully you notice that because they have the same slope. So then I want to test 0, 0. Is 0 greater than or equal to -2? Yes, that's true, so I want to shade towards this way. So I want to do this. There is my common area in between there. Okay, so remember, solid line, okay, same slopes, I mean they're parallel, but I'm looking at which way am I going to shade. So if I took a look at the system of inequalities, so this is always fun because I'm not in slope-intercept form yet. So before I do that, let's do this. Let's see if I can get them in slope-intercept form without too much trouble. So if I take x minus y less than or equal to -1, so what I can do two things. I can either find intercepts or I can convert it. So if I find intercepts, x equals 0, so -y greater than or equal to -1, so that means y would be less than or equal to 1, or y equals 1, that would be my point. I just pretend it's equals. All right, then y equals 0, so x would equal -1. Sorry, this would be +1. So y equals 1, x equals -1. So it'd be right there. It's going to be a dotted line. That should be a dotted line, believe it or not. And then I can test it. Is 0 minus 0 greater than or equal to -1? Is 0 greater than or equal to -1? Yes. Shade towards it. So second one here. So 3x minus y less than or equal to 4. So if x equals 0, -y equals 4. So y equals -4. So I put a point down here. So if I let y equal 0, then 3x equals 4. So x equals 4/3. So that's going to be right about there. So if I draw that line straight, so now let's test 0, 0 here. Well, is 3 times 0 minus 0 less than or equal to 4? So 0 less than or equal to 4? Yes. So I shade towards it. So my common area becomes this right here. That's what I'm looking for. All right, so now if I throw 3 of them in here, let's figure out what the heck is going on. So you want to find the coordinates of the vertices of the figure formed by the system of equalities. So you've got 3 situations here. So you got y less than 3 minus x. So if I want to rewrite that pretty easily, I can go -x plus 3. Y greater than or equal to -1, x greater than -1. So if I graph these, it's going to look like this. So plus 3, -x means it's going to go dotted, like so. So 0 less than -0 plus 3 is 0 less than 3, yes. Boom, 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 boom. And for the second one, y greater than -1, well, y is equal to -1 right down here. So greater than means I'm going up. The last piece, x greater than negative 1. X at negative 1 is going to be here, and it's going to be dotted. And that's going to go this way. So my common area here is going to be right here. But now you can't just do that. What's the question asking? The question's saying, hey, where do all these things cross? Well, they cross right here, and right here. That's where they all cross. So I'm going to cross at negative 1, 4, negative 1, negative 1, and then at 4, negative 1. So there is that is where those all cross. And that's what they're at. All right, so get going on your homework. I know this is not always true, but unfortunately it is always necessary. All right, come talk to me with questions.